Okay, this was I recently heard about this. It's a surprising fact to me, and I was unaware of it. All right, so I'm unaware of many things, but when I'm shown things, I'm often kind of like perplexed about the patterns that exist that I didn't know existed before. But let's read the problem to you. It says f of x is a real coefficient cubic polynomial with three real roots, and the roots are ordered a, b, c. It goes on to say that the tangent line at x equals a plus b over 2, and that's the average between the first two roots. That tangent line will go through the third root, all right? So if you visualize that, let me put out what I mean by visualizing that. If I saw the cubic polynomial like this, I just say generally like this over here, and I got the three roots over here. I'll call this the root A, I'll call this the root B, and I'll call this the root C. Now granted, it's not drawn perfectly, but maybe it's really not drawn well, so I really have to draw that again. So let me do that again, because I want it to look like what I want it to look like, which emphasizes what that story tells me, all right? So let's take a look at this over here. I'll put down A, B, and C over here. And let me just draw a tangent line through there and over here, and just draw this cubic in now. And the cubic's going to look sort of like this over here. All right, that's the cubic. And again, it's not perfectly drawn, I realize that. But this point over here supposedly is going to be, let's see, A plus B over 2, f of A plus B over 2. And what am I claiming over here? That the slope of the tangent line there is, the derivative value at A plus B over 2, and it'll intersect the x-axis at C. So let's go through it and try to verify that this is indeed true. The first thing I recommend is just write the polynomial down. And the polynomial will be of this form if we have the three roots A, B, and C, with the understanding that k is not 0. All right, these are real coefficient polynomials. Yeah, you multiply it out. Someone says, do I need to multiply it out? It might make it easier to take its derivative. So I multiplied it out. We got a nice pattern to it, pattern you probably know about already. Then I take the derivative. The derivative, fairly easy to do, by the way, particularly if you multiplied it out first, easy to do. And then I evaluate the derivative at this value here. Now, granted, it was work, and what I mean by that is this took work. By the way, I'm not going to say this took much work, but this took some work. I'll put down some work here. All right, but the evaluating the derivative at A plus B over 2 was some work, but I got this. All right, I got this. What we need to do now is verify that that the equation of the tangent line at the x value A plus B over 2 is going to intersect the x-axis at C. So that's what we need to do. So we need to verify the tangent line has an x-intercept here. So I just write the equation of a tangent line down. What's it going to be? Well, y minus the function evaluate, again, it's a tangent line at A plus B over 2, is equal to the derivative at that value of x, and then x minus that value, which is A plus B over 2. All right, so, again, we just verified a couple things. For example, let's see what I wrote down over here. I think I just wrote it down twice, didn't I? So, oh no, I didn't. I actually, let's see what I did over here. Yeah, I'm putting in the 0 and a C in. I didn't write that twice, just put 0 C in there. And then I do this. This is minus K, and I write this down. That's the easy part. We did this. That's up here, by the way. I'm doing simplification over here. I'm kind of looking at that. And I want to say it looks pretty crazy to me. I'm going to simplify it a tiny little bit. And let's take a look. So I divide both sides by k, and then I factor this 2 out here, and I get the minus 1/8. I'm definitely seeing that. And the a minus b squared, and this would just be 2c minus a minus b. All right, let's do the other side. And I think I'd factor out the 2's, and I'd factor out a minus 1 from this guy over here. All right, so what would I get? Well, 2 times 2 is 4, 8, minus 1, no, it's plus 1/8. And then I get a minus b squared. That's coming from these two over here. Then I get this. All right, let's look at it. And what I'm noticing now is that the sides are the same. 1/8, a minus b squared, a plus b minus 2c. So yeah, we just verified what they said is true, right? Remarkable. What do you mean by remarkable? I didn't know this was the case. And then certainly when I heard it, I said, I wonder if I could verify if that's true. And it's really not that difficult to verify, all right? Now granted, let me repeat this. If you need to reach out to me, I would say come by during office hours or ask during class time. But you can also reach out to me by email. And my email address is Bannon. That's B as in boy, the @ symbol, NNON.US. And again, thank you for paying attention. Bye-bye.